In this video, we're going to look at relative error. Let's try an example. So let's say that we've got the following formula from physics, m is equal to 2e over v squared. We know that the maximum relative error in the kinetic energy is plus or minus 2%, and the maximum relative error in the speed plus or minus 3%. So based on that, we want to find the maximum relative error in the mass. All right, so this is all about differentials. Let's flash back to the differential of a function f, df. If f depends on x and y, then df would be f sub x times dx plus f sub y times dy. Now in this case, the function that we're interested in is mass. So we're going to rephrase this as dm, and mass depends on the energy and the speed. So we're going to write dm equals m sub e times dE plus m sub v times dv. All right, so when we write dm here, that's our absolute error. So we're going to go ahead and calculate that, but we'll have to remember later on to divide by m in order to turn that into a relative error. So let's focus first on just calculating dm. So dm, we'll take the partial of m with respect to e. That's going to give us 2 over v squared times dE plus partial of m with respect to v. You could think of this m here as 2e v to the negative 2. So then taking the partial with respect to v, that's going to be minus 4. I'm actually going to change the sign there. So minus 4 e v to the negative 3, so I'm going to write that over v cubed times dv. So now to turn this into a relative error, we want to calculate dm over m. So we're going to go ahead and divide each term by m, and remember m was equal to 2e over v squared. So let's multiply by the reciprocal. V squared over 2e is going to get multiplied by each term. And again, we're going to have a v squared over 2e multiplying on here to represent dividing by m. And let's simplify these terms. So in the first term, v squareds are going to cancel out, 2 is going to cancel out, and we're going to have dE over e. In the second term, e's are going to cancel, factor of 2 will cancel, and v squared will cancel, just leaving us with a v. So we're going to have minus 2 dv over v by the time we rearrange that. So this is saying that the relative error in the mass then is going to be the relative error in the kinetic energy minus 2 times the relative error in the speed. So our goal is to maximize this quantity. And to do this, we're going to have to be careful about the signs. So let's go back to our given information. We were told that the maximum relative error in the kinetic energy was plus or minus 2%. Okay, so if we wanted to maximize dE over E, we could use dE over E equals 2%. But then for the second term, it's going to be a little bit different. You can see the second term has a negative coefficient. So if we overall want to maximize the relative error in m, we actually want to use a negative quantity for the relative error in the speed. So we're going to use dV over v equals negative 3%. And that's going to make our dm over m as big as possible. So intuitively, why this is happening, if we go back to the formula, notice that the v squared is in the denominator. So this is like saying if you underestimate your speed, that's going to overestimate your mass. And so that's why we're seeing the negative 3% there as being the right quantity to use to maximize dm over m. Okay, so subbing in these values then, just continuing from our line above the box, we're going to have 2% minus 2 times negative 3% to give us 8%. Okay, so we could say the maximum relative error in the mass is, well, if we're talking just in terms of absolute value, it's 8%, but really it's plus or minus 8%. So if you wanted to achieve a relative error in the mass of negative 8%, you would do that just by reversing the signs. If you had a relative error in the kinetic energy of negative 2%, and if you had a relative error in the speed of positive 3%, so just reversing the signs of what we did up here, that would then give you a relative error in the mass of negative 8%. So usually when we're talking about maximum error, we just figure out the maximum absolute value of the error, and then we report it. When we report it, we say plus or minus that number. So that's an example of how we can use differentials to calculate relative error. Thanks for watching.